Solid Edge provides its users with a powerful and intuitive experience when creating wire harnesses. In today's project, we'll be finishing up a harness design by adding some additional lighting for a bulldozer cab. We'll start by making the necessary changes to our harness schematic in 2D and then move it into 3D to finalize the design. Creating electrical schematics in Solid Edge is as simple as connecting the dots. Using a 2D schematic to connect all of our components together is a great way to visualize how the system is going to work. Here, we have pictorial representations of all of our electrical components known as blocks. The great thing about designing electrical schematics in Solid Edge is that we're provided with an entire library of these blocks ready to use, or that can easily be changed to meet whatever needs we have. Alternatively, if a block has already been created in another schematic, even within another software package such as AutoCAD, it can easily be reused as well. To finish up our schematic, Solid Edge can automate the creation of a block table that can pull all of the important information that we need from our components. Now that our schematic is done, let's see how Solid Edge routes wires in 3D. As we remove the walls of the bulldozer cab, we can see a large majority of the cab wiring has already been completed. The section of the cab we'll be focusing on is the lights on the top frame. For this portion of the wiring, as is commonplace in industry, we'll be using a 2D ECAD system to generate wire and connector information for our cab layout. As the harness wizard takes us through the steps to import the data, we'll get a good look at how easy this is. First step, select the files that contain the schematic data. The second step gives us a nice view of the components that the wires attach to. If there are multiple instances of the same component, Solid Edge lets us know so that we can select which one we want to use. Easy! The final step in the wizard is to ensure that all of our wires, cables, and bundles have been assigned to their associated connectors. After a quick check to make sure that everything's where it's supposed to be, we can finish the import and watch as Solid Edge automatically generates the wires, knowing that they're all in the right place, a huge time saver for large electrical systems. Now that the wires have been placed, routing them is easy using Solid Edge's intuitive tools. First, we want to place all of these individual wires into a cable and run it up through the clips. Once inside the cable command, Solid Edge provides us with instructions on what we should do every step of the way. Providing these easy to understand instructions makes it simple to learn and use any command inside of Solid Edge. Once our wires have been selected, we'll quickly create a new cable path up through the clips. Now that we've got our main cable coming up from the controls to the roof, let's get our lighting components properly wired and placed. We've seen how easy creating a new path is, but what about rerouting cables that have already been placed? Not to worry, that's even easier. Select the cable, select the clips, and Solid Edge handles the rest. But what happens if we need to add additional wires into an existing cable or bundle? Here, we need to clean up the interior light wires to combine them with the main harness. While we could easily create and route another path, why not just simply split an existing path and add the wires there, using that existing route location to easily clean up the harness. Also notice when we create a physical representation of the newly created bundle, the diameter changes with the added wires giving us real results so that we know what to expect when this harness is physically created. We've seen how we can work with existing wires inside of our model, but now we need to create a couple of wires from this front left light to our switch panel. Creating wires in Solid Edge is just as simple as importing. Notice once again how easy Solid Edge makes routing using existing geometry. Now that we've got our wires in place, we need to make sure that these wires bundle nicely with the rest of the harness. Once again, using existing paths is a great way to get the proper wire runs we need. A quick selection of our two wires and we have the freedom to bundle them into any paths that have already been created. Simple and clean. Solid Edge also offers some other great tools such as splicing. Keeping consistent with intuitive commands, adding a splice is as easy as selecting which wire, where you want to splice it, and then use that as an anchor point for the wires you want to splice in, just as you would in real life. Additionally, if you're working with purchased cables of certain length in your assemblies, Solid Edge easily accommodates for that as well. Simply input the length that the wire will be, and notice that even if the component that it's connected to is moved, the length stays the same. Of course, once our harness has been completed in the assembly, we can easily output all of the information directly back to our ECAD system, making sure that our wire sizes and lengths are appropriate for their use. The final step in harness creation is making a nailboard drawing representation. Nailboard drawings allow us to have a real-size 2D representation of exactly which wires will be bundled together and which connectors they'll use. This 2D representation will be attached to a piece of wood, and the physical harness will be built over the top of the drawing to ensure accuracy. Solid Edge offers complete control over outputs of the 2D nailboards, allowing us to organize them however we want. This includes adding bins to optimize space, all while maintaining exact lengths, a very important part of creating a wire harness. Solid Edge also creates views of connectors attached to the wires with all associated pin information. Combine that with automatic creation of a conductor table to show the individual details of the wires themselves, from material and color to cut length and diameter, and you can see how Solid Edge ensures accuracy when building harnesses. Solid Edge, design better.